The saga of wild boars in America traces its roots not to the continent's forests or swamps, but to the rolling decks of Spanish galleons crossing the Atlantic more than 5 centuries ago. These first swine were not wild at all, but domesticated animals, descendants of Eurasian wild boars, selectively bred for centuries for their meat, hardiness, and adaptability. Released into a land teeming with unfamiliar scents and sounds, some pigs wandered off, while others were intentionally set free to fend for themselves, their fate now intertwined with the wild landscapes of the New World. Over generations, these escapees adapted to their new environment, forming the earliest feral swine populations, creatures neither fully wild nor truly domestic, surviving in the shadows of southern swamps and forests. For centuries, these animals remained a minor presence, their numbers kept in check by predators, disease, and the challenges of the wild. The story of the wild boar, however, is ancient and global. Native to the dense forests and open woodlands of Eurasia and North Africa, Sus scrofa has long been a symbol of resilience and adaptability. These animals are omnivorous generalists, capable of thriving in a vast range of habitats, from icy northern woods to arid Mediterranean scrub, thanks to their intelligence, social structure, and remarkable reproductive capacity. In their native range, wild boars play a crucial ecological role, aerating soil as they root for food, dispersing seeds, and serving as prey for large carnivores. Their adaptability, however, is a double-edged sword. When introduced to new continents, these same traits can turn them into formidable invaders. In the early 20th century, the American landscape changed again. Eurasian wild boars, with their thick coats, sharp tusks, and fierce temperament, were introduced for sport, blending with the established feral pig populations. The resulting hybrids combined the domestic pig's prolific breeding and adaptability with the wild boar's strength, aggression, and survival instincts. This new lineage flourished, their populations growing slowly at first, then surging as they exploited every available niche in the American landscape. Today, an estimated 6.9 million feral hogs roam the United States, their range expanding with each passing year, undeterred by natural barriers or human attempts at control. Their spread is astonishing, outpacing even the prolific white-tailed deer, driven by their intelligence, adaptability, and sheer reproductive power. The explosion of feral hogs has been likened to the rabbit plague that devastated Australia, a slow-motion ecological upheaval reshaping the American heartland. From a handful of escapees to a continent-wide crisis, the wild boar's journey is a testament to the power of adaptation and the unforeseen consequences of introducing a species into a new world. Today, feral hogs are found in at least 35 states, their impact felt from the bayous of the South to the plains of the Midwest. Texas, with its sprawling landscapes and mild winters, now harbors the largest population, an estimated 2.6 million hogs present in nearly every county. Their relentless march is propelled by their own resilience, as well as by the altered landscapes and abundant food sources of modern America. What began as a simple act of animal husbandry has become a sweeping ecological force, reshaping habitats, outcompeting native species, and leaving a lasting mark on the American environment. The relentless expansion of wild boar populations across the United States has triggered a cascade of economic and ecological consequences, the scale of which is both staggering and deeply concerning. Each year, the financial toll inflicted by feral hogs is estimated to exceed $3 billion nationwide, a figure that encompasses not only direct crop losses, but also the hidden costs of land restoration, equipment repair, and lost productivity. These losses ripple through rural economies, undermining the stability of agricultural operations and threatening the viability of entire communities that depend on farming and ranching. In Texas, the epicenter of the wild boar crisis, Annual damages surpass $500 million, with vast tracts of farmland left scarred and unproductive. The destruction is driven by the hog's instinctive behaviors, rooting, wallowing, and foraging, which transform carefully managed fields into landscapes of churned earth and shattered vegetation. Corn, sorghum, soybeans, rice, and even specialty crops like peanuts and melons are all vulnerable, with entire harvests sometimes lost in a single night. The speed and scale of this devastation are remarkable. A single sounder, sometimes numbering over 30 individuals, can obliterate up to 24 acres of mature crops overnight, resulting in tens of thousands of dollars in losses. These large coordinated groups move with surprising stealth and efficiency, making them difficult to deter or contain. Nighttime raids are especially destructive, as hogs exploit the cover of darkness to feed and root undisturbed, compounding the challenge for land managers. The economic burden extends beyond crops. Feral hogs routinely damage fences, irrigation systems, and farm machinery, forcing landowners into a cycle of costly repairs and replacements. Their powerful bodies and relentless determination allow them to breach even reinforced barriers, leading to containment issues for livestock and further compounding losses. In their search for water, hogs uproot underground irrigation lines, sometimes causing tens of thousands of dollars in damage in a single incident and disrupting water delivery for entire growing seasons. Orchards and tree plantations are not spared. Wild boars strip bark, break branches, and uproot young trees, jeopardizing long-term investments and reducing future yields. The ecological consequences are equally severe, though often less immediately visible. Wetlands, forests, and grasslands are all transformed by the presence of wild boars. As opportunistic omnivores, wild boars consume a vast array of foods, from roots and tubers to insects, small vertebrates, and the eggs of ground-nesting birds. Their broad diet allows them to exploit nearly every available food source, often outcompeting native species and reducing the abundance of key resources for wildlife. Wild boars are also formidable predators, consuming the eggs and young of reptiles, amphibians, and mammals, including vulnerable species such as ground-nesting birds, turtles, and even deer fawns. Their aggressive foraging and predation disrupt native food webs, displace wildlife, and contribute to the decline of sensitive and endangered species. The physical impact of wild boars on the landscape is profound. Their rooting and wallowing behaviors accelerate soil erosion, destroy native vegetation, and alter the structure of entire ecosystems. Wallowing in wetlands, ponds, and creek beds, wild boars create muddy depressions that degrade water quality and eliminate critical habitat for amphibians and aquatic plants. These wallows increase sedimentation, reduce water clarity, and disrupt the delicate balance of aquatic ecosystems. Riparian zones, vital buffers that protect waterways from erosion and filter pollutants, are especially vulnerable as hogs trample vegetation and destabilize banks, leading to increased runoff and habitat loss. The constant defecation of wild boars in and around water sources introduces harmful bacteria, including E. coli and Salmonella, into the environment. Scientific studies have documented bacterial contamination in streams frequented by hogs at levels up to 40 times higher than in unaffected areas, posing a significant risk to aquatic life and ecosystem health. This pollution threatens not only fish and amphibians, but also livestock and wildlife that depend on clean water, turning once pristine streams and ponds into potential health hazards for all species downstream. The wild boar or feral hog stands as a paragon of adaptation and intelligence in the animal kingdom. Far from being a mere domestic pig gone feral, this species is the product of millennia of natural selection, resulting in a creature exquisitely attuned to survival in a vast array of environments. Every aspect of the wild boar's physiology is a testament to its evolutionary success. Its robust, muscular frame is built for both power and endurance, allowing it to traverse rugged terrain, dense forests, and open fields with equal ease. Adult boars can weigh several hundred pounds, yet they are capable of astonishing bursts of speed, reaching up to 48 kilometers per hour, making them elusive targets for natural predators. Agility is another hallmark of their design. Wild boars can leap over barriers exceeding a meter in height, and their compact, flexible bodies enable them to squeeze through dense undergrowth or tangled roots, evading obstacles that would hinder less adaptable animals. Their most iconic feature, the tusks, are not merely for show. These continuously growing canine teeth are sharpened by the constant grinding of the upper and lower jaws, forming formidable weapons that can exceed 15 centimeters in length. Tusks serve as both tools and defenses, capable of inflicting serious wounds on would-be predators or rivals. The wild boar's hide is another marvel of adaptation. Over the shoulders, a thick, shield-like plate of skin and dense subcutaneous fat, sometimes up to 4 centimeters thick, provides protection against bites, stings, and even the attacks of other boars. This natural armor allows them to withstand injuries that would incapacitate other animals, and it is a key factor in their resilience. Endurance is further enhanced by their remarkable resistance to environmental extremes. Wild boars thrive in climates ranging from humid subtropical forests to arid grasslands and even snowy woodlands. Their coarse, bristled fur insulates against cold, while their ability to wallow in mud helps regulate body temperature and protect against parasites. Yet, it is the wild boar's intelligence that truly sets it apart. These animals possess a highly developed brain relative to their body size, supporting advanced cognitive abilities. Their memory is exceptional. A boar that encounters a threat or a novel object can remember the experience for months, sometimes years, and adjust its behavior accordingly. Wild boars are adept problem solvers. They investigate new objects with caution, learn to avoid dangers such as traps, and can even manipulate simple mechanisms to access food. Observational learning is common. Piglets watch and imitate their mothers, quickly acquiring skills necessary for survival. Social structure within wild boar groups, known as sounders, is complex and dynamic. Typically led by an experienced sow, these groups operate with remarkable coordination. The lead sow guides the group to food and water sources, teaches the young to recognize edible plants and roots, and demonstrates how to avoid natural hazards. Communication among wild boars is sophisticated, involving a range of vocalizations, grunts, squeals, and scent markings. These signals convey information about food, danger, and social status, enabling the group to respond collectively to changing conditions. Adaptability extends to their daily routines. When faced with increased threats, wild boars shift their activity patterns, becoming more nocturnal and altering their routes to avoid detection. They are sensitive to subtle changes in their environment, such as the scent of predators or the presence of unfamiliar objects, and will modify their behavior to minimize risk. The wild boar's ability to analyze risk and adapt strategies is evident in their foraging behavior. They exploit a wide variety of food sources, from roots and tubers to insects, small vertebrates, and even carrion. This omnivorous diet allows them to thrive in habitats where other species might struggle. In every sense, the wild boar is a master of survival, physically formidable, mentally agile, and endlessly adaptable. Their intelligence and resilience ensure that they remain one of nature's most persistent and resourceful inhabitants, continually evolving to meet the challenges of an ever-changing world. Beyond the visible destruction they cause to land and property, feral hogs represent a significant and often overlooked threat to the health of livestock, native wildlife, and the broader ecosystem. These animals are walking reservoirs for an alarming number of diseases and parasites, many of which can be transmitted to other animals through direct contact, contaminated environments, or shared water sources. Wild boars are known to carry at least 30 different viral and bacterial diseases, including brucellosis, pseudorabies, tuberculosis, and foot and mouth disease. Their wide-ranging movements and social behaviors make them highly effective vectors, capable of spreading pathogens across vast territories and into new animal populations. Brucellosis, a bacterial infection, is particularly concerning. It can cause abortions, infertility, and reduced milk production in cattle and other livestock, leading to severe economic losses. The bacteria can persist in the environment, contaminating soil and water, and can be transmitted to other animals through ingestion or contact with infected tissues. In Texas, studies estimate that up to 1/3 of the feral hog population tests positive for brucellosis, making the state a hotspot for potential outbreaks among livestock. The list of health threats does not end there. Wild boars are also carriers of pseudorabies, a viral disease that is fatal to many domestic animals, including cattle, sheep, goats, and companion animals such as dogs and cats. While pseudorabies does not infect humans, its impact on animal health and agricultural productivity is profound. Outbreaks of pseudorabies can devastate herds, causing neurological symptoms, respiratory distress, and high mortality rates, especially in young animals. The virus can be shed in saliva and nasal secretions, contaminating feed, water, and the environment. Feral hogs are frequent carriers of enteric pathogens such as Salmonella, Leptospirosis, and E. coli. These bacteria are shed in their feces, which can contaminate water sources, irrigation systems, and agricultural fields. Leptospirosis, in particular, can persist in moist environments, infecting a wide range of mammals and causing kidney and liver damage. Contaminated water sources pose a direct risk to livestock and wildlife, as animals drinking from these sources can become infected. Irrigation of crops with contaminated water can also introduce pathogens into the food supply, increasing the risk of disease outbreaks. The internal parasite load of a typical feral hog is extraordinarily high, often 10 to 15 times greater than what is found in commercially raised domestic pigs. These parasites include roundworms, tapeworms, flukes, and protozoa, many of which can infect other animals through contaminated soil, water, or feed. As wild boars root and wallow, they deposit parasite eggs and larvae into the environment, creating hotspots of infection for other animals. Some parasites, such as Trichinella and Toxoplasma, can persist in the environment for extended periods, increasing the risk of transmission. While direct attacks on livestock are rare, wild boars can injure or stress domestic animals, leading to secondary infections or reduced productivity. Their aggressive behavior, especially when protecting young or food sources, can disrupt grazing patterns and force wildlife and livestock into less optimal habitats. Wild boars also pose a significant threat to native wildlife. They compete for food, destroy nests and burrows, and can transmit diseases such as tuberculosis and classical swine fever to wild ungulates and other mammals. This can lead to population declines and disrupt local ecosystems. Their rooting and wallowing behaviors degrade habitats, increase erosion, and alter water quality, which can stress aquatic species and reduce biodiversity. The spread of invasive plants is often facilitated by the soil disturbance caused by wild boars, further impacting native flora and fauna. Carcasses of wild boars that die from disease can serve as reservoirs for pathogens, attracting scavengers and increasing the risk of disease transmission within the ecosystem. Some pathogens, such as anthrax and African swine fever, can persist in carcasses and soil for months or even years. The primary route of disease transmission to other animals often comes after the hunt, when carcasses are field-dressed and processed in the open, potentially contaminating the environment and exposing scavengers and other wildlife to infectious agents. Blood and bodily fluids from infected wild boars can harbor a range of pathogens, including viruses, bacteria, and parasites. These can be spread by insects, scavengers, or through direct contact with contaminated soil and vegetation. Ongoing surveillance and laboratory testing have confirmed the presence of multiple zoonotic pathogens in wild boar populations, underscoring the importance of monitoring and managing these animals to protect animal health and agricultural interests. To mitigate these risks, experts recommend strict biosecurity measures when handling wild boar carcasses, including the use of protective gloves, thorough disinfection of equipment, and safe disposal of animal remains to prevent environmental contamination. Proper cooking of wild boar meat is essential to eliminate parasites and bacteria, health agencies advise that all wild pork be cooked to an internal temperature of at least 160 degrees Fahrenheit, and that cross-contamination with other foods be strictly avoided. Ultimately, the health risks associated with wild boars extend far beyond their immediate presence. Their ability to move across landscapes, interact with diverse animal populations, and persist in a variety of habitats makes them a persistent and complex challenge for animal health, agriculture, and ecosystem stability. For decades, the escalating crisis of feral hog overpopulation has been met with a familiar arsenal of traditional control methods, tools and techniques that, while once considered effective, have proven increasingly inadequate in the face of the wild boar's remarkable adaptability. These methods, cage trapping, box traps and corral traps, are designed to physically contain wild boars, but their effectiveness is fundamentally limited by the animal's intelligence and social structure. Wild boars live in complex social groups called sounders, led by experienced sows. These matriarchs are highly cautious, often investigating new objects or disturbances before allowing the group to approach. As a result, traditional traps frequently capture only the youngest or least wary individuals, leaving the core of the population untouched. The partial capture of a sounder not only fails to reduce numbers meaningfully, but also serves to educate the survivors. These animals quickly learn to recognize and avoid traps, associating them with danger for years to come. Over time, this selective pressure has produced a population that is not only more elusive, but increasingly nocturnal. Wild boars shift their activity patterns to avoid human presence, making them even harder to locate and control. Compounding the problem is the wild boar's extraordinary reproductive capacity. A single sow can produce 2 litters per year, each with up to a dozen piglets. Even if a portion of the population is removed, the rapid rate of reproduction quickly replenishes their numbers. This reproductive advantage allows wild boars to expand into new territories, exploiting gaps left by failed control efforts. Each failed trapping or hunting attempt not only leaves survivors but also encourages the spread of the population into previously unaffected areas. The intelligence of wild boars is a critical factor in the failure of traditional tactics. Once exposed to a trap or hunting pressure, they quickly adapt their behavior, avoiding not only the specific device but also any similar structures or scents. This learned avoidance is passed on to younger generations, creating a cycle in which each new cohort of hogs is more difficult to capture than the last. Traditional hunting, whether by ambush or pursuit, often has the unintended consequence of dispersing sounders across the landscape. Instead of reducing numbers, these efforts can fragment groups and drive survivors into neighboring habitats, spreading the problem rather than containing it. As wild boars adapt to human pressure, they exploit a wide range of environments, from dense forests to agricultural fields and even suburban edges. Their omnivorous diet and resourcefulness allow them to thrive in nearly any setting, further undermining traditional control efforts. The cumulative effect of these failures is a population that is not only larger, but also more elusive, more nocturnal, and more challenging to manage with each passing year. The persistence and adaptability of wild boars have rendered traditional tactics obsolete. Each failed attempt not only leaves the core of the population intact, but also ensures that future efforts will be met with even greater resistance. The result is a landscape increasingly shaped by the presence of wild boars, fields torn up, crops destroyed, and native ecosystems disrupted, while the animals themselves remain largely beyond the reach of conventional control. In the end, the wild boar's intelligence, social complexity, and reproductive power have outpaced every traditional tactic deployed against them. The challenge now is not simply to remove individuals, but to fundamentally rethink our approach to managing this formidable and ever-evolving adversary. Across the varied landscapes of Texas and beyond, the Coyote, Canis latrans, has emerged as a pivotal player in the ongoing struggle to manage feral hog populations. While often misunderstood and maligned, The coyote's ecological role is far more complex and beneficial than previously recognized. Coyotes are highly adaptable predators, thriving in environments ranging from dense forests to open grasslands and even encroaching into urban and suburban areas. Their ability to exploit a wide variety of food sources has allowed them to expand their range across nearly the entire continent. In recent years, detailed field studies and genetic analyses have revealed that coyotes are not merely opportunistic scavengers when it comes to feral hogs. Instead, they have developed a specialized predatory behavior targeting the most vulnerable stage of the hog's life cycle, the piglet. By analyzing coyote scat and stomach contents from multiple regions, including Texas, Oklahoma, South Carolina, and Georgia, researchers have consistently found evidence of freshly consumed piglet tissue, bones, and DNA. This indicates that coyotes have learned to actively hunt and consume feral hog piglets, rather than relying on carrion or accidental encounters. The hunting strategy employed by coyotes is both sophisticated and highly effective. Packs will approach piglet nests with caution, remaining downwind to avoid detection by the protective sow. They wait patiently for the sow to leave the nest in search of food, then execute a coordinated rush. This hit-scatter-kill method creates chaos, scattering the piglets in all directions. In the confusion, a coyote can quickly seize a piglet and retreat before the sow can return to defend her offspring. This behavior is not innate, but learned and passed down through generations, demonstrating the coyote's remarkable intelligence and adaptability. The ecological impact of this predation is profound. In areas where coyotes are present, piglet survival rates remain low, naturally limiting the explosive growth of feral hog populations. However, in regions where coyotes have been removed or suppressed, studies have documented dramatic increases in piglet survival, rising from just over 20% to nearly 70% in some cases. This surge in piglet survival leads directly to rapid population growth among feral hogs, intensifying their destructive impact on native ecosystems, agriculture, and biodiversity. The removal of coyotes, therefore, disrupts a crucial natural check on feral hog numbers. This unintended consequence highlights the importance of maintaining balanced predator-prey relationships within ecosystems. By preying on feral hog piglets, coyotes provide an essential ecosystem service, helping to curb the spread and impact of one of North America's most damaging invasive species. Their role is a testament to the intricate and often underappreciated dynamics of natural systems, where even a misunderstood predator can become a vital ally in the ongoing battle to restore ecological balance. As wild boar populations have surged and traditional control methods have proven inadequate, a new era of technological innovation has emerged, one that leverages advanced engineering, data analytics, and remote monitoring to address this ecological challenge with unprecedented precision. At the forefront are smart trapping systems, which have evolved far beyond the simple mechanical cages of the past. These modern traps are equipped with a suite of sensors, infrared motion detectors, weight sensors, and even thermal imaging, to accurately identify the presence and number of wild boars entering the enclosure. These systems are often constructed as robust, modular corrals, scalable to accommodate entire sounders. Integrated cameras, both infrared and low light, provide continuous surveillance, while 4G and satellite connectivity enable real-time data transmission to remote operators. Operators, often miles away, can monitor these feeds on secure mobile or desktop platforms. The system allows for precise timing, waiting until the entire group, including the elusive matriarch, is inside before remotely triggering the gate. This ensures maximum capture efficiency and prevents survivors from learning to evade future traps. The ability to capture entire groups at once is a breakthrough, eliminating the risk of educating survivors and providing valuable data for population management. Each event is logged, with analytics used to refine future trapping strategies. In expansive or inaccessible regions where ground trapping is impractical, aerial surveillance and intervention have become essential. Helicopters equipped with high-resolution thermal cameras and GPS mapping systems can rapidly locate and track wild boar herds even in dense vegetation or at night. Aerial teams utilize these technologies to coordinate rapid response operations, efficiently reducing populations over large tracts of land. The integration of real-time telemetry and advanced optics allows for precise, humane targeting, minimizing collateral impact on non-target species. Specialized companies now offer these high-tech aerial services, utilizing custom software for mission planning, execution, and post-operation analysis. While resource-intensive, these methods can achieve population reductions in hours that would otherwise take months. Each operation is meticulously documented, with digital records supporting adaptive management and regulatory compliance. The data collected informs future strategies and helps quantify the impact of aerial interventions. These aerial methods are particularly valuable in remote or ecologically sensitive areas, where rapid population reduction can provide immediate relief to native flora and fauna, as well as agricultural interests. Parallel to mechanical and aerial solutions, chemical control agents, known as toxicants, are being developed and refined. These substances, such as warfarin and sodium nitrite, are formulated to target wild boars specifically, with delivery systems engineered to minimize risk to non-target species. Bait stations are designed with weighted lids and access mechanisms that require the unique strength and rooting behavior of wild boars, effectively excluding other wildlife. These systems are field-tested under strict protocols to ensure environmental safety. Sodium nitrite, a fast-acting toxin, is currently undergoing rigorous trials. Automated monitoring systems record all activity at bait stations, providing data on efficacy and non-target exposure, which is critical for regulatory approval and public acceptance. The deployment of toxicants is governed by comprehensive risk assessments, with environmental sensors and digital checklists ensuring compliance with safety standards. This approach, while controversial, is increasingly seen as a necessary tool for large-scale population management when used responsibly. The most effective results are achieved through integrated management, combining smart traps, aerial operations, and targeted toxicant deployment, all coordinated through centralized data platforms. Predictive modeling and real-time analytics enable adaptive strategies, maximizing efficiency and minimizing unintended consequences. Programs such as the USDA's Feral Swine Eradication and Control Pilot have demonstrated that a coordinated, technology-driven approach can reduce wild boar populations by 60 to 70% within 2 years, as evidenced by aerial surveys and statistical analyses. While no single technology offers a complete solution, the persistent application of advanced tools, guided by data and ecological insight, marks a turning point in the battle against this invasive species. The future of wild boar control lies in the seamless integration of innovation, science, and adaptive management. When wild boar populations surge beyond ecological balance, land managers and policymakers are confronted with a fundamental question: should these animals be managed through consumption or through direct population control? In natural systems, wild boar populations are kept in check by predation, food scarcity, and disease. However, in many human-altered landscapes, these natural controls are insufficient, leading to overpopulation and significant ecological disruption. In parts of Europe, wild boar are integrated into the food system. Their meat is processed under strict sanitary conditions, and the animals are harvested from regulated populations, ensuring both food safety and ecological balance. In these regions, consumption is not merely a culinary tradition but a management tool. Regulated hunting seasons, quotas, and veterinary inspections ensure that only healthy animals enter the food chain, while also keeping populations at sustainable levels. The process is highly regulated, Every carcass is inspected for zoonotic diseases such as trichinosis and brucellosis, and only those passing rigorous standards are approved for sale and consumption. This creates a closed-loop system where wild boar are both a resource and a managed species, with economic incentives aligned to ecological goals. The result is a sustainable model where consumption supports population control and the market demand helps fund ongoing management efforts. In contrast, the United States faces a very different reality. Despite a vast and growing feral hog population, the commercial consumption model has not taken hold. The primary barrier is biological. American feral hogs are vectors for numerous diseases and parasites, many of which can be transmitted to humans and livestock. Pathogens such as brucellosis, pseudorabies, and trichinella are prevalent, making the meat potentially hazardous without comprehensive testing and processing. Federal regulations require that all meat sold commercially must be inspected and processed in certified facilities, a standard that is logistically and economically unfeasible for wild harvested animals on a large scale. As a result, most wild boar harvested in the US are not processed for human consumption, and their carcasses are often left in the field or disposed of as waste. Legal frameworks such as the Federal Meat Inspection Act strictly prohibit the sale of uninspected wild game meat, effectively closing the door to a commercial market for feral hogs. This regulatory barrier is compounded by the logistical challenges of collecting, transporting, and processing wild boar from remote or inaccessible areas. Without a viable consumption pathway, population control efforts in the US focus almost exclusively on direct reduction through trapping, culling, and exclusion, rather than utilization. These methods are labor-intensive and costly, often requiring specialized equipment and ongoing maintenance to be effective. Physical barriers and deterrents are also employed, but wild boar are highly adaptable and can quickly overcome many control measures. Advanced technologies such as aerial surveys and GPS tracking are increasingly used to monitor populations and target control efforts more efficiently. Aerial culling is sometimes employed in large, open landscapes, but this method is controversial and can have unintended ecological consequences, such as leaving large numbers of carcasses in the environment. The absence of a consumption-based management system means that the ecological impacts of wild boar, soil erosion, crop loss, competition with native species, are addressed primarily through removal, not utilization. The control industry has responded with a suite of specialized tools and strategies, from automated trapping systems to remote monitoring, all designed to reduce populations as efficiently as possible. Yet wild boar are intelligent and adaptable, often learning to avoid traps and changing their behavior in response to control efforts, making long-term management a persistent challenge. Without natural predators and with high reproductive rates, populations can quickly rebound, requiring ongoing and adaptive management strategies. Ultimately, the debate between consumption and control in wild boar management is shaped by ecological realities, regulatory frameworks, and the biology of the species itself. In regions where consumption is feasible, it can provide a sustainable, economically viable means of population management. Where it is not, direct control remains the primary tool, with all its associated costs and challenges. The ultimate goal, regardless of method, is to restore and maintain ecological balance, ensuring that wild boar, whether managed through consumption or control, do not overwhelm the landscapes they inhabit. The challenge of feral hogs remains formidable, but the path forward is evolving into a sophisticated, science-driven campaign that harnesses the full complexity of the landscape itself. Rather than isolated efforts, the future of wild boar management is rooted in landscape-scale strategies that adapt to the unique ecological mosaic of each region. There is no single solution. Success will depend on a dynamic blend of methods, each precisely matched to the terrain, season, and local wildlife community. The backbone of this approach is technology. Smart traps, remote cameras, and real-time tracking systems will allow for rapid detection and targeted removal of entire sounders, minimizing collateral impact on non-target species. Management will be coordinated across property boundaries using digital mapping and data-sharing platforms, ensuring that control efforts are synchronized and that wild boar populations cannot simply shift from one area to another. By continuously monitoring damage patterns and population movements, managers can deploy resources where they are needed most, responding to new incursions before they escalate. In dense forests and riparian corridors, large-scale smart trapping will remain the most effective tool for removing entire family groups, while drones and aerial surveillance will track elusive individuals across open terrain. Night vision cameras and acoustic sensors will provide round-the-clock intelligence, revealing movement patterns and habitat preferences that inform future interventions. In expansive rangelands, aerial operations will be deployed with precision, guided by real-time data to maximize efficiency and minimize disturbance to other wildlife. Ground-based methods, such as targeted trapping and habitat modification, will address residual animals and prevent re-establishment in managed zones, where ecologically justified and strictly regulated, innovative toxicants may be used in highly controlled settings with rigorous safeguards to protect native species and water quality. At the same time, the future of management will increasingly value the role of natural predators, coyotes, bobcats, and raptors, whose presence helps suppress wild boar recruitment, especially among vulnerable piglets. Ongoing research into predator-prey dynamics will guide habitat restoration efforts, ensuring that these natural checks are maintained and enhanced. The lessons of the past have shown that every intervention can ripple through the ecosystem, so adaptive management will be essential, constantly monitoring outcomes and adjusting tactics to avoid unintended consequences. By fostering healthy, resilient ecosystems, managers can tip the balance in favor of native species, making landscapes less hospitable to invasive wild boar. The future of wildlife management is holistic, integrating ecological, technological, and adaptive strategies to sustain the entire community, not just control a single species. The ongoing effort will be measured not by the total eradication of wild boar, a goal now recognized as unattainable, but by the restoration of balance where their numbers and impacts are kept in check by a resilient, well-managed landscape. As these integrated strategies mature, the visible scars of wild boar damage will fade, replaced by healthier soils, thriving crops, and the quiet return of native wildlife. The vision is not one of conquest, but of coexistence, where wild boar are managed as part of a living, dynamic system, and the land itself is the ultimate beneficiary. Through relentless innovation, ecological insight, and a commitment to stewardship, the future of wild boar management promises a landscape where both agriculture and biodiversity can flourish. It is a long, complex journey, but with integrated management, adaptive science, and respect for nature's own solutions, we are forging a sustainable path forward, one where the wild boar dilemma becomes a story of resilience, balance, and hope for the land. Across continents, the wild boar has become one of the world's most adaptable and widespread invasive mammals. Originating from Eurasia and North Africa, their natural range once spanned temperate forests and grasslands. But as centuries passed, deliberate introductions and accidental escapes propelled them far beyond their historical boundaries. Today, wild boars roam the woodlands of Europe, the islands of the Pacific, and the farmlands of the Americas, each new landscape shaping their behavior and impact. Their global spread is a story of remarkable mobility. Wild boars are capable swimmers, crossing rivers and even short stretches of sea, enabling them to colonize fragmented archipelagos and isolated wetlands. Their migration patterns are often driven by a relentless search for food, seasonal shifts, or disturbances like floods and droughts. In mountainous regions, they traverse steep slopes and dense undergrowth, while in agricultural lowlands, they follow irrigation ditches and crop edges, exploiting every available resource. Their home ranges can expand rapidly when resources are scarce, with family groups, known as sounders, roaming dozens of kilometers in search of new territory. As these animals move, their environmental impact multiplies. In North America, their rooting behavior transforms prairies into patchworks of bare earth, disturbing native grasses and accelerating erosion. In Australia, wild boar wallows muddy, fragile wetlands, threatening endangered amphibians and spreading invasive plant seeds. Across Asia and Europe, their omnivorous diet puts pressure on ground-nesting birds, reptiles, and even small mammals, while their robust digestive systems allow them to consume and disperse a wide range of seeds, often favoring invasive flora. The global march of the wild boar is also reshaping disease dynamics. Their migrations create corridors for parasites and pathogens, linking distant wildlife populations and bridging the gap to domestic livestock. In regions where natural predators are scarce, wild boar numbers surge unchecked, amplifying their ecological footprint. In places like New Zealand and Hawaii, where they are wholly non-native, their presence triggers cascading effects, from altered forest regeneration to the decline of endemic species found nowhere else on Earth. Yet the wild boar's spread is not uniform. Geographic barriers, climate extremes, and human interventions shape the edges of their advance. In cold northern latitudes, only the hardiest survive, while in arid deserts, water scarcity curtails their numbers. But wherever they establish, wild boars adapt swiftly, forging new migration routes and exploiting novel food sources. Globally, the challenge is no longer local containment, but coordinated international management. Data sharing between countries, real-time tracking of transboundary populations, and region-specific strategies are emerging as essential tools in curbing their advance. The story of the wild boar is a lesson in the unforeseen consequences of species translocation and a stark reminder of the need for vigilance at the intersection of ecology, agriculture, and global biosecurity. In this ever-shifting landscape, the wild boar continues its relentless march, an emblem of adaptability but also a catalyst for ecological change on a planetary scale. In the intricate web of ecosystems, wild boar populations are not left entirely unchecked. Across their vast and varied range, a select group of natural predators plays a crucial, if often underestimated, role in regulating boar numbers. These apex and mesopredators form a living barrier against explosive population growth, each with their own tactics and territory. In the dense forests of Eastern Europe and Russia, the elusive grey wolf emerges as the wild boar's primary adversary. Wolves hunt in coordinated packs, using teamwork and endurance to single out vulnerable individuals, often targeting piglets or weakened adults. Their presence not only reduces boar numbers through direct predation, but also alters wild boar behavior, forcing them to avoid open spaces and remain vigilant, which in turn limits destructive rooting and feeding patterns. Further south, the Eurasian lynx, though solitary and stealthy, occasionally preys on young or injured boars. Its ambush tactics are most effective in rugged, forested landscapes where cover is abundant. Meanwhile, in the mountain ranges of the Caucasus and parts of Central Asia, the brown bear adds another layer of predatory pressure. While bears are omnivorous and opportunistic, they will not hesitate to prey on boar piglets or scavenge carcasses, subtly influencing survival rates within sounders. Beyond Eurasia, natural checks persist. In the Mediterranean, the golden jackal, and in North America, the mountain lion, also known as the cougar or puma, both exert predatory influence. Mountain lions, in particular, have adapted to hunt wild boar in regions where their ranges overlap, using stealth and powerful bursts of speed to ambush their prey. On the islands of Japan, the formidable Ussuri brown bear, and, to a lesser degree, large raptors, such as eagles and hawks, prey on boar piglets. These aerial hunters snatch the vulnerable young from open clearings, further demonstrating the diversity of natural control mechanisms. Yet, despite these natural forces, wild boar remain remarkably resilient. Their high reproductive rates and adaptive behaviors often outpace predation, especially in regions where apex predators have declined or vanished due to habitat loss or human activities. In such cases, mesopredators like foxes and coyotes may opportunistically prey on piglets, but their impact is limited. The delicate balance between predator and prey is a testament to the complexity of ecological relationships. Where robust predator populations persist, wild boar numbers are naturally moderated, reducing the need for human intervention and helping maintain ecosystem stability. Conversely, in landscapes stripped of their natural hunters, wild boar can surge to ecologically disruptive levels. The story of wild boar and their predators is one of adaptation, resilience, and the enduring power of nature's checks and balances. It underscores a fundamental ecological truth. When natural predators thrive, they become invaluable allies in the ongoing challenge of managing one of the world's most adaptable mammals. Wild boars, with their relentless search for food, are architects of change in every landscape they invade. Their impact on native flora and fauna is profound, with consequences that often cascade far beyond the initial disturbance. In the forests of the southeastern United States, wild boars root through the undergrowth, turning leaf litter and soil in pursuit of tubers, insects, and seeds. This destructive foraging, known as rooting, can strip the forest floor bare, uprooting native plants and exposing the earth to erosion. In the wake of their passage, rare orchids and delicate wildflowers, some found nowhere else, may vanish, unable to compete with invasive weeds that quickly colonize disturbed ground. A striking case unfolds in the Hawaiian Islands. Here, wild boars introduced centuries ago have become a significant threat to native rainforests. Their rooting disrupts the fragile understory, destroying habitats for endemic birds like the Akiapolao and the Hawaiian crow. The pigs also create wallows, muddy pools that serve as breeding grounds for mosquitoes, which in turn spread avian malaria to already imperiled bird populations. The result is a perilous decline in species that once flourished in isolation. In the wetlands of the Iberian Peninsula, wild boars pose a different challenge. Their appetite for ground-nesting birds' eggs has led to marked reductions in populations of species such as the Eurasian curlew and the red-legged partridge. The boar's omnivorous diet means that amphibians, reptiles, and even small mammals are not spared. In some regions, researchers have documented wild boars preying on the eggs of endangered turtles, further exacerbating conservation struggles. Australia faces its own battle. In the tropical north, wild boars trample through sensitive floodplains, muddying the waters and destroying aquatic plants vital for native fish and waterfowl. Their presence disrupts the breeding cycles of frogs and damages the nests of ground-dwelling birds, while their consumption of native fruits and seeds reduces the regenerative capacity of indigenous forests. These case studies reveal a common thread. Wild boars are ecosystem engineers, often to the detriment of native biodiversity. Their ability to alter habitats, consume a vast array of species, and outcompete native fauna for resources makes them a formidable ecological force. As wild boars continue to expand their range, the challenge of protecting native flora and fauna grows ever more urgent. Each new region invaded brings a fresh set of ripple effects, reminding us that the true cost of wild boar proliferation is measured not only in lost crops or damaged landscapes, but in the silent disappearance of species that have called these places home for millennia.